Hello everyone, we're back with lesson 5.5 on first differences in chapter 5, modeling with graphs. We're really looking at two things in this lesson, and I've written them down here at the top. So we're looking at different ways that we can represent a relation. So we're going to discuss that, and we're going to discuss ways that you can determine if the relation you're looking at is a line or not. So first differences is a technique we use to determine if a relation is a line. So I'll just hone in on that again so you can see that note. Okay, so we have four ways of representing a relation here. One is a table of values. I've highlighted them in orange. So these are examples of table of values. Another way is we could list them as ordered pairs. So that's this way. On the back, we could graph a relation. So if you look at graphs, that's another third way. And the fourth way is we could use equations. We're going to look at all four ways and how to determine from each way whether you have a line or not. So the first method we use is on table of values is called first differences. So if you have a linear relationship, that means you will have constant first differences. And the word constant means always the same. As the x values change by a constant amount, the y values will also change by a constant amount. A different amount, but it'll be constant between the x's and constant between the y's. There is a special case, and that is when the y values are always the same or the x values are always the same. Those are two unique cases that you have to watch out for. So let's go to the first example. So this is a table of values that comes off a graphing calculator. And you can, actually I gotta remove some stuff. If you look at this first table of values, you can see you have to check, before you can find first differences, you have to check that your x's are increasing or decreasing by the same amount every time. So this goes 2, 3, 4, 5. I can see that these are going up by 1 every time. So the x's are changing by a constant amount. If that's happening, then you're ready to take first differences. And first differences is the following. You're going to find the difference in the value of y. So you're going to go like this and say, hey, 6 take away 5 is 1. And then you move to the next one. 7 take away 6 is 1. 8 take away 7 is 1. And if you keep doing this all the way up, you're going to see the difference in the y's is always 1. That is the first subtraction you've done, and that's called first differences. If when you do this, you discover that all of these numbers are the same or they're constant, then you know that that is a line. So this is a line. The next example. This is going up -2, -1, 0, 1, 2, 3, 4. So I can see that these are always going up by 1s. So the change in x is constant. The y's, if I look at those, I can see, hey, it goes from -5 up 2 to get to -3. I can go -3 minus -5 and get 2. You subtract -1 minus -3, and I also get 2. And I keep doing this, and I can see that it's always a 2, and I check, and so that's constant, and therefore this is a line. Here's another one. -3 to -1. So the difference between there, -1 minus -3 is 2. That's going up by 2 this time. But if you look, the next one is also going up by 2, and the next one's also going up by 2. So they're constantly going up by 2. And since they're constantly going up by the same number, we can take first differences and decide whether we have a line or not. So over here, when we subtract each one, you're going to see that the difference is always 1. Okay, it's always -1 actually, sorry. So 3.5 minus 4.5 is -1, and 2.5 minus 3.5 is also -1. And if you keep going, you always get -1 everywhere. So it's constantly -1. Since the difference in the y's is always the same number when the difference in the x's is the same number, you know you have a line. Actually, before we go on, is that the one I want to do? No. Let's just try to relate that back to one of the units we did before. You've heard me talk before about difference in x's and difference in y's. Difference in y's over difference in x's, that's simply the slope. And we know the slope of a line is constant. It always has to be the same number. So we can calculate the slope by taking the difference in the y's was 1 every time. The difference in the x's was 1 over time. So the difference in the y's over the x's is 1 over 1. And so the slope of this line is 1. This one here, the first differences in the x's were increasing by 1. So the difference in our x's was 1. The difference in our y's was 2. So the slope of this line was 2 over 1, or 2 was the slope. This line here was a little different because this was changing. The first differences were always the same, and so we knew that this was a line. They were always -1. The difference in the y's was -1. The difference in the x's was 2. So the slope of this line was the difference in the y's over the difference in the x's. So its slope was -1/2. You can see why first differences helps tell us whether we have a line or not, because all it's really doing is checking that the slope is always the same number. It doesn't really matter what that number is, but it has to be the same all the time, and that's what decides it's a line. Okay, there's two special cases, and that's this one. That was my highlighter. Okay, so this one, if you notice, in the X column, you can see that the difference is always 1. It's going up by 1 every time. It's always the same. This one is going up by 0 every time, or it's not changing. If you notice that the y's are not changing at all, you can say, well, I know slope is simply the difference in the y's over the difference in the x's, so that's 0 over 1, and so that slope is 0, and I know of a special line that has a slope of 0, and so that's a line. And let's just look at this. Let's just take 2 points and draw a little sketch of what's happening here. Let's take 0, 1, and 1, 1. Let's take a third one, and 2, 1. You can see, yes, I've got a horizontal line, and I know that it has a special slope of 0, and I kind of figured that out anyway. So this is a line, even though it's looking a little bit weird. There's no real change, right? The second one is the other case. We can see that the x's are not changing. They're always a 5. X is always 5. In this case, if you did a little sketch to see, hey, what's going on? These are always changing by 0, and these are changing by, it doesn't really matter what they change by, because I could actually, well, that's interesting. Okay, so they're going up by 1s in this case, but let's say I only gave you this one, and I skipped one. Let's say I didn't show you that one. You'd be like, okay, 5, 5, 5, -1, 0 take away 1 is 1, and 2 takeaways, hey, that's 2, that's different, and you might think, wait a minute, it's not constant. But the problem is I've just left out some points in between, and you don't know that. But what should trigger you is that these are all the same, and then you have to realize, oh, I don't need to worry about that because these are all the same. If those are all the same, you know that you have an x value of 5, and let's say I take 2 of these points, 5, 0, and 5, 2. Oh, that's the vertical line, right? A number over 0 is undefined for slope, and that's an undefined slope. So those are two special cases of the table of values that you have to notice, that all the y's are the same or all the x's are the same, and those are lines. Otherwise, you just have to make sure that the x's are changing by the same amount every time, and then the y's are changing by the same amount every time, and then you know you have a line. These are examples of non-lines. This is not a line because when you find the difference between the x values, they're all going up by 1, but these do not go up by the same number every time. 1 take away 4 is 3. Sorry, 1 is -3. This one's going down by 3. And then, so the first step is it goes down by 3. The next one is -1. And then it starts to go up. And it goes up by 3, etc. Okay, so it continues. All those numbers are different. They're not the same. Therefore, it's not a line. The next one. These ones are all going up by ones. And so I can check if this is a line. These have to be all going up by the same amount every time. And if they are, I can check first differences. Over here, I can see, okay, this one went up by 0.25 the first time. And then the next time, hey, it went up 0.5. I don't even have to check anymore. As soon as I found two that aren't the same, then I know it's not a line. And then we've got this one. Oh, actually before, no, okay, I'll keep going. So we've got 2, -10, 1, -7, etc. So this one goes down by 1, down by 1, down by 1. So this is constantly going down by 1 in the x's, and so I know that I can check for first differences. So let's check. This is -7 minus -10. Be careful with the negatives like this, that you do it in the right order and get the correct first difference. So -7 plus 10. And then this one here is -4 minus -7, which is -4 plus 7. And then, have I done something wrong? -2 minus -4 is 2 plus 4, which is 6. So at first it seemed like this might be a line because I had 2 in a row, unless I made a mistake, 2 in a row that had the same, were constant. They had the same first difference, but then the next one wasn't the same. So you need to check more than one to conclude that you have a line. But the moment you see that your first differences aren't the same, you can stop. You don't need to show that there's more that aren't the same. You just have to show that at one point in time it's not the same, then you can say not a line. All right, I just want to go over a concept here, and that is I'm just using the example from, oops, that's kind of shiny. I'm using this first example here. I've just rewritten it over on this, and I'm going to have to turn the light off because it's shining right on it. Funny. So is this one. I don't know if I can fix that. Dun, dun, dun. Do I really have to turn out the lights? Yeah, I guess a bit. Okay, sorry for all that. All right, so just a word as to why it's called first differences. So here you have a table of values with x and y and all the values. And we already calculated all the first differences and saw that they were different. So this is the first difference that we're talking about. Difference is subtraction. So I subtracted the y's to get these different numbers. And I noticed that they were not constant, and therefore this was not a linear relationship. And therefore, if I were to graph these points, they would not form a line. If I were to take the difference again, this would be the second time I'm taking the difference. The difference between these 2 points, -1 minus -3, doing that right, is -1 plus 3, which is 2. The difference between here, 1 minus -1 is 1 plus 1, which is 2. 3 minus 1 is 2. 5 minus 3 is 2. And 7 minus 5 is 2. So when we calculated first differences, they weren't all the same, and so it was not a line, and it will not graph as a line. And that's all you really need to know today, is that first differences have to be the same to have a line, and if they're different, not a line. But just so you understand why it's called first differences is because we could go ahead and take second differences, and we could go and do it again and take third differences. You can keep going. When you take the second difference, you notice, hey, these are all constant. And this is something you're going to learn next year in grade 10, that the second differences are constant. And therefore, this is what we call quadratic. Not a line. It's going to graph like a U. This one would graph like a line. Well, not that one because I said it isn't. So you don't have to know this yet, but I just want you to know it because I think it helps you understand why it's called first differences. It's the first time you take the difference. And all you need to know today is that if the first differences are constant, you have a line, and if it's not a line. You don't need to know this part here about quadratic, but it's kind of interesting. Okay, so let's go to number 2. Number 2 is showing that relations can be listed as ordered pairs. So this was in table format, and this is in ordered pair format. And you do the same thing here to decide whether it's a line or not. It's just visually not as nice. I'm not going to do them all, but I'm just going to show a couple. So if you can see that as I go from this point to that point, 2 to 3 to 4 to 5, my x's are increasing by 1 every time. And I can see as I jump my y's, 5 to 6 to 7 to 8, they're going up by 1s every time. So I can see that the first differences are constant and it's a line. Similarly, I can repeat and go through these other ones and see that they're also lines. I can also go over here and do the same thing and realize, hey, they're not all the same. They're not lines. This is going up by 1s each time, and yet the difference here is down 2, and then it seems to be down 3. Okay, it changes, so those are not lines. There are 2 special ones here, though. This one goes up by 2, up by 2, up by 1. Okay, so the change in the x's was not always the same, but we can still look at the first differences and see what's happening with our y's. The y's went up by 1, they went up by 1. It's looking like a line because when I went up by 2 and went up by 2 again, I went up by 1 and I went up by 1 again. Let's look at this next one. I went up by 1 instead of going up by 2, and when I did that, my difference was 1, the same as before when I was going up by 2. So here, even though my first differences appear to all be a 2, it doesn't work because that's only good if my change in my x's are constant, and the change in the x's was not constant. So this is not a line. Okay, this one too I want to look at. It's a little tricky to look at like this as they get a little harder. And so you might want to go and instead take the time, if I can get far enough away, to change it from this format into a table format so you can see what's going on, because otherwise it can be hard sometimes. So for this example, you can see that it goes from -1 to 0. That went up by 1. And then I went up by 2. And then I went up by 3. So this was going up by different amounts. It's hard to tell what the first differences are there. I could go like this and say -1 minus -3 is equal to 2. Because this is not going up by the constant same amount, it doesn't really matter what this is doing because I can't judge if my first differences are the same unless these are going up by the same amount. But I can see a pattern. I can see that when I go up 1 here, I go up 2 here. So let me check and see if I can fill in some things that are missing. What if I went up by 1 more? What number should I be at? Oh, I should be up 2 above -1. So that would take me to 1. Okay, maybe that's right. When I go up by 1 again, I land at 2. Maybe I should draw this. Up by 1, that's a 2. If I go up by 1 again, that's a 2. Now I'm missing 2 numbers here. I'm missing 3 and 4. So let's just check what would happen if I filled that in. If I were to add 2 to this, I'd be at 5, 7, and 9. That's good. So I can see, even though some of the points were missing, when I fill them in, I can see that, oh yes, if I were increasing by 1s every time, am I increasing by the same amount here every time? And the answer is yes. And therefore, this has constant first differences, but it took a little more work on your part to figure it out. Okay, that's the end of that. And now we're flipping to the back. 2 more ways to represent relations is as a graph and as equations. What's really nice is if you have a graph and you have to find out whether it's a line or not, it's pretty simple. Does it look like a ruler drew that graph? And if the answer is yes, it's a line. So all of these are line. They're straight. These are not lines. They're not straight. Very easy to tell. Don't have to calculate anything. The last one is the equations. Next unit, you're going to be learning how to write the equations of lines, and you're going to be using the slopes and the points and some information that we've already seen. So you haven't really seen this yet, but I'm just going to show you that these are the equations of lines. They're the formulas for drawing lines. The way you look at them and decide whether you have a line or not all depends on the format. Lines will have a y in them. Sorry, there's two special cases, so I'll come back to that. So all lines will have a y and an x, or just a y in it, or an x. Those are the special horizontal or vertical lines, but they'll have a y and an x in them, and the exponents on the y's and the x will be 1. So notice how you don't see any exponents on them? That's because, it's a 1 and we don't write that. So you're going to have an equal sign with an x and a y, and the exponent on the x and the y, or just the x or just the y, will be 1. Those are all lines. These are also equations that have x's and y's in them, or just x's or just y's. I think they all have both. And so at first you might be like, oh, those could be a line. But if you notice, exponent of 2 on x, not a line. Exponent of -1 on x, not a line. Ooh, different exponents, not a line. Exponent of 2, not a line. This one at first might appear like, hey, that looks like an exponent of 1. But if you recall from your exponent unit, you will realize that that's how you write a negative exponent is 1 over. So if you remember, if you had 3 to the -1, that would equal 1/3. If you have x to the -1, that's written as 1 over x. So when you see 1 over x, you need to realize that that exponent is not a 1. It's a -1. So none of these are lines. So you can see that, easiest way, obviously, if you look at it, if it looks straight, it's a line. Not straight, not a line. Equations, pretty easy. You see exponents on the x's or y's, not a line. This one's the one that requires some work, and that's why this unit was about, or this lesson was about how to do that work, which was first differences. You have to calculate first differences. And remember, this first sentence is the most important thing. As the x values change by a constant amount, if the y values change by a constant amount, that's when you have a line. And so that's what you need to be checking. Okay, that's the end of that lesson.